Hello everyone. Okay, welcome back to the good stuff that we have been doing. Today in this video, we're going to try to evaluate this integral, which is integral from 0 to infinity of t to the s minus 1, 1 plus e to the t dt. And it says it equals to gamma of x, eta of s. Here, eta of s is the sum of negative 1 to the k as k runs from 1 to infinity of k 1 over k to the s power. Now, for example, here eta of 2 here would be the sum as k runs from 1 to infinity of 1 over of negative 1 to the k, and then you would have k to the second power, and this is related to the Dirichlet zeta function. Why gamma of s? Of course, gamma of s is defined to be the integral from 0 to infinity of t to the s minus 1 e to the negative t dt. Of course, believe so. So this is how both functions are defined, and we're trying to this is the integral relationship between them. And one way to prove this is to notice that we can express this denominator as a geometric series. For example, we know that 1 over 1 minus x is the sum as k runs from 0 to infinity of x to the k power. So for that reason, we are going to express 1 over 1 plus e to the t power as multiply both top and bottom by e to the negative t. You will get e to the negative t all divided by 1 plus e to the negative t power. Oh, so this would be equals to, this of course would equals to e to the negative t all divided by 1 minus negative e to the negative t power. So basically now we have this integral, which is the integral from 0 to infinity. Let me write different color. So here the integral from 0 to infinity would be t to the s minus 1 power all divided by 1 plus e to the t dt, and this integral would equal the integral from 0 to infinity of what? You have t to the s minus 1, then you have the sum as because this would equals the sum as k runs from 0 to infinity of what? You would have e to the negative, you have e to the negative t, negative 1 to the k power rather. You have negative 1 to the k. Okay, we don't have negative 1 to the k. You just have e to the negative t dt, e to the negative t. Yeah, e to the negative kt in this case here. Then, so, but because of the e to the negative t, you have also extra factor of e to the negative t as well. So this would be the k runs from 0 to infinity of e to the negative t, then e to the negative kt, and then the t, obviously. Then this would equals the integral from 0 to infinity of t to the s minus 1. Then you have the sum as k runs from 0 to infinity of e to the negative k plus 1 t dt. Now, you can shift the index backward by 1 times. If you replace k plus 1 by t, then by n, then n will start from 0. Okay, so this would definitely equal the integral from 0 to infinity of t to the s minus 1, then the sum as n runs from 0 to infinity of e to the negative nt dt. Now, the question asked here is that, can we swap summation and integration? Like, can we, instead of taking the integral, maybe we take the sum of the integral first? Well, we can only do that if maybe we are sure that they are both convergent. Now, when is this this is going to be convergent within the limits we have, but when is this definitely convergent? This is convergent, obviously, as long as, because if you evaluate the integral from 0 to infinity of t to the s minus 1, let's say dt, you have 1 over t to the s. You have 1 over t to the s from 0 to infinity, I believe so. So you have, I think you have s, yeah. Yes, you have s over t to the s power from 0 to infinity. Now for the infinity case, if you take derivative of the top and the bottom, because if you plug in infinity, you get infinity over infinity, but if you take derivative of top and the bottom, derivative of t to the s with respect to s will be log st to the s. So this would be convergent so long as s is greater than 1, or rather we say the real part of s is bigger than 1, has to stay positive. That is only when this integral is convergent. If in the case of s, let's say even s is negative, if s is say negative and you put it in this form, you will have a positive value of t to the s and it will always diverge in that case. So when s is negative, it will always diverge. So so long as the real part of s is bigger than 1, this would be convergent. So in this setup here, we're going to assume the real part of s is bigger than 1. Then we're going to swap summation and integration. You would have, this is the sum as n runs from 0 to infinity of what? The integral from 0 to infinity of t to the s minus 1, then e to the negative nt, then dt. Now notice here that by definition of the gamma function, here we have 1 over k to the s, or 1 over k to the s to equals gamma of s times the integral from 0 to infinity of t to the s minus 1 e to the negative k t dt. So if you replace n here by k, and you will notice that everything here, everything here would equals the sum. Let's replace n by k. K equals to 0 to infinity of 1 over k to the s power times gamma of s. Okay, so now, okay, don't forget the negative 1 to the n, obviously. I think we have a negative 1 to the n here. Yeah, so negative 1 to the n power, and then you have negative 1 to the n power. Of course, negative 1 to the n power always. So you would have negative 1 to the n power. Then this is eta of s, obviously, times gamma of s by definition here. So we have proved this result that the integral from 0 to infinity of t to the s minus 1 divided by 1 plus e to the t dt is gamma of s eta of s. So thank you for watching, and please do subscribe to the channel. Bye.